Welcome everyone to the Fall 2021 AGSA R Workshop. This session specifically on the topic of data wrangling and iteration. Thank you very much to Dr. Leonardo Bastos, who is a postdoctoral researcher still here at the house, K-State University, in cropping systems and remote sensing. And he's probably moving, we're going to miss him a lot. He's probably moving pretty soon to Georgia State University. So we took the chance and got one more session of this nice workshops with him. So thank you very much, Dr. Bastos. And with this, I pass you the command of the session today.
Sounds great. Thanks, Adrian. And thanks for you guys to inviting me again this year. It's always been great to be conducting these workshops and hopefully getting more people, familiarized and aware of these great resources that we have with our. All right, so I guess just a quick agenda for today. Hopefully, you guys have been through my GitHub repository for this workshop already and downloaded the material. If you have not, you will likely not be able to follow along, but this is going to be recorded. So if that's the case, you can still do that at a later time. So today we're basically going to go through two sessions. So the first session is going to be going through some data wrangling functions that I particularly use a lot on my workflows. And then the second part is going to be about iteration. And when we get there, we're going to talk a little bit more about what that is and what it means and how that can help us to do things more efficiently. Okay, let me switch back here. So if you guys don't have yet, I want to invite you to open the Rstudio project that you downloaded from the GitHub repository. And you should, if you just launch it, you may not be seeing a script up here. If that is the case, you can click on that R blue button to take you to the main folder of the project. And then you can go under Markdown folder and launch the session1_partial script. And once you do that, you're going to be seeing what I'm seeing here. So let's something that I just want to point out before we get started. If you have questions related to like the content, or maybe I'm speaking too fast and you wish that I was going slower, something that's like that more people can benefit from, please feel free to put that on the chat. And even if you want to open up your mic and speak up, you're welcome to as well. However, if you have any technical issues, meaning your code is not running, your packages are not working, something like that, we're not going to have the time to really stop and figure those out on an individual basis. So unfortunately, if you have those issues, we're not going to be able to help you right here. But definitely after the workshop, I'm more than happy to help anyone that for some reason got stuck somewhere, not sure why got stuck. We can work those out later. And again, this is going to be recorded, or it is being recorded. So you guys are going to have this as a resource for later as well.
Mm-hmm. Leo, just may I add something regarding to that topic. If you have any questions, I will be more than happy to help if I can do it in the background. So we will try to figure out not to interrupt you during a session. So hopefully we finish by 6.
Okay,
so if you
perfect.
have any questions, you can send me a message. I'm Adrian Correndo there in the chat, so I will be more than happy if I can help.
Awesome. And Carlos said that he can help too. So yeah, if anyone has technical issues, please feel free to reach out to Adrian or Carlos, and they would try to help you out. All right, so let's get started. So again, this is not an intro to our workshop, meaning that if it's the first time you're seeing R, this may be too much. So we're already expecting you to have some familiarity with R and Rstudio projects, R Markdown files. But having said that, let's just get started with actual coding here. If you just want to go ahead and run this first chunk to just load all the packages that we're going to be using, please go ahead and do that. And for some reason, mine is taking some time. Not sure why. You know what? I think I'm going to restart my R because it's really looks like something's going on in the background and I'm not sure why. So I'm just going to restart my session. Fun stuff. So let's see if that helps. Okay, back to that screen. And let's try again. Okay, now it's kind of going perfect. So the first thing we're going to do here after we loaded all these packages is to read in the data set that we're going to be using. So that's going to be called soyk. I already left some of the code there for you. And it is an Excel file. And to bring that Excel file into R, we're going to use this function read_Excel. And if you want to move your cursor in between the parentheses there, open and close quotation marks, have your cursor in between the quotation marks and hit tab. So the first thing we see is all of the contents of the markdown folder, which is where the script is saved. We need to get outside of that folder and get into the data folder. To get outside of the markdown folder, we do .. and hit tab. So now we're going to see the contents of the main folder of this project. So we can click on data and hit tab again, and it's going to autocomplete for us that soybean workshop.xlsx file. We can just run that. And once you do that, if you were successful, we're going to see this object soyk appearing on your environment up there. And also we can explore this a little bit just by printing right below here. So if you have attended any of my previous workshops, we actually have used this data set in the past for data wrangling purposes. And I just wanted to reuse it because I think it has some key aspects that I think are worth exploring and showing. So the first thing here, just checking the first rows of this data set, and also the columns here, what we see is there's lots of different naming styles, let's say, that for these columns coming directly from Excel, right? So here plot is uppercase, only the first letter, treatment is uppercase, everything, stage is all lowercase, and then some columns we have spaces and we have parentheses in the name. All these things are kind of messy, and I would much rather work with like a standardized naming convention for these columns. And that's basically what we're going to do the first thing. But before, actually, let me take a step back and just tell you a little bit about what is this data set. So this is a study that was conducted on 4 different locations. So we have here A1, O2, S1, and W1 are the locations identifiers for this data set, where the treatments were different potassium fertilizer rates, and that we can see here on this column K rate, pounds per acre. And then at this stage R4, and this is in soybeans, and so at the R4 growth stage in soybeans, people went out there and collected petiole samples from the soybeans and sent to a lab for being analyzed for potassium concentration in the tissue. And so these KPCT is the percentage potassium in the plant tissue measured at each one of these 4 locations. And then they had, it was a randomized complete block design. So they had 4 reps, 4 blocks in the study. And this is basically what this study is. It's just one measurement of potassium concentration on leaf, on petioles, in soybeans in 4 different locations. So something that I usually like doing when I just bring data into R is to just do some exploratory data analysis from the sense of just looking at the data and having a feeling if things make sense. So the first one that I want to use here is this function called glimpse. And then we just say soyk, which is our data set, and you can just run that and look at the output right below it. So we see here, just give us like the column names that we have right now, and then if they're double or numerical, or if they're a character. So we see here that plot is being seen as numerical, as double, and the only one really being interpreted by R as character is stage. Everything else is being interpreted as numerical. Another different way of quickly looking at this is using, so if we go to the next chunk here and we use the function summary and say soy k inside of that, we can also take perhaps a different look in this data set, right? So everything that is numerical or double up here, the summary function is just going to show us basically some summary statistics from those variables. And this is really, especially like if we look at the variables that were measured on the field, which are these 4 here on each of the 4 locations, it's really just interesting to see like the minimum and the maximum especially, and see if those values make sense, right? Since they are percentages, everything makes sense, like ranging from 0.6% all the way to 3.5 or 3.3. That makes sense, right? I mean, if we had a value here that was like 100, maybe that wouldn't make much sense, and then that's something we would have to look into. So always great to check using the summary function. And also, it's not the case here, but if we had any NAs in this data set, it would show up here as an extra row saying and number of NAs, and then it would tell us that information. That's also important. Okay, so we took a quick look at this data set, and everything makes sense, at least like from I guess from what you would expect those values to be, biologically speaking, they all make sense. So let's start doing some wrangling. So the first thing that I want to do here is just to clean the names, like all these column heading names here that don't really have a standard right now, right? So for that, we're going to call this object soyk_1, and then we can use the assign symbol, and we're going to use this function called clean_names that comes from the janitor package, and we're going to just say soyk. Or yes. Anyone has a question or no? Okay, maybe it was just by mistake. So I'm just going to keep going. So if you run this, and then right below here, you just paste again soyk_1 and print it. We're going to see like what happened after we apply this clean names function. So we can see now that like plot, treatment, stage, everything has been changed to lowercase. And this is actually something you can control. That's a default. If you wanted everything uppercase, you could have changed to that, or camel case, which is just like the first letter of words being capitalized and everything else being lowercase. So there are different ways of doing that. Here this is really what I want to just have everything lowercase, and notice how like we had, so like K rate pounds per acre, before this was named like that. So we had spaces and we had the parentheses, and now everything is like very easy to use for modeling, for example, and even data wrangling. We're going to see that in a second here. So awesome. This is something I normally use in my workflows, is just to get the names cleaned and standardized, and that's usually my first step on my data wrangling efforts. So awesome. Let's go to our second chunk of data wrangling here, which is using the function filter. So if we think about it, filter is a function that's going to be applied to your rows. It's going to do a row by row filtering in the sense of just filtering to a given value. And what I want to do here, just as an exercise, is for us to filter and retrieve from this data set that has, so right now this data set has 16 rows, right? And let's say if I wanted to retrieve just a given potassium rate, so all the data rows that had potassium rate equals to 0, how would I do that? So we can basically come here to the soyk_2, that's how we're going to call it, give it the assign symbol, and use the function filter. So the first thing we have to say is the data name. So that's going to be, let's use So this is important, right? So we started off with soy K, but now soy K_1 already has the names cleaned. So let's just use that version here. So provide soy K_1 as a data set going into the filter function. And then I'm just gonna hit enter just to make it easier to see the code. And let's say if my goal here is to filter only potassium rates equal to 0. If we just use this function here named soy K, which was already in your script, this basically, soy K_1 actually, sorry, my bad. We actually now see the names of the columns currently. And I do that just so it makes it easier for you to copy and paste like that instead of having to type out. I'm just gonna copy here K rate, pounds per acre, and just say equals 0. So if I run that, and then I print here soy K_2 by just pasting its name and running it, we're gonna see now that this data set, this soy K_2 only has 4 data rows, and those were the ones where potassium rate was 0, right? So of course, this example is very simple, but sometimes you really need to filter things for whatever reason. I use a lot this function here when I'm doing data wrangling. So that's how you would filter on a row basis, like only selecting rows that match a given value for a given column. Awesome. So now let's go to the next chunk here where we have soy K_3. So the goal of this chunk is going to be to transform. So if we look at our data set, even just the filter one, we have potassium rate in pounds per acre, but we do not have potassium rate in kilograms per hectare. So let's say if this is your research and you're getting your plots ready for a publication, they're going to have to use the international units or the metric system rather than the pounds per acre or the English system. So let's just transform or create a new column where we do have the potassium rate in kilograms per hectare in this data set. So let's call this soy K_3. We use the get symbol. We're going to use the function mutate. So the function mutate is basically the function that creates new columns in your data frame. That's what it does. So the first thing we have to do here is just say the data set that we want to start, right? And we could use soy K2, but we're not. We're going to use soy K_1 because soy K_2 was just an example of how we filter. But moving on, I actually want to use the entire data set. So let's just go back to using soy K_1 here on the mutate as the entering data set. And then if you want to add a comma, hit enter. Let's call this K_rate_kilograms per hectare. This is going to be the name of our new column, right? That the data set doesn't have yet. We use one equal sign, and then if you just want to come here and just copy this name, or just you can even type if you want. I'm just copying because I'm being a little bit lazy. So kilograms per hectare is going to be, we're going to provide the formula to convert pounds per acre to kilograms per hectare. So that's basically our rate in pounds per acre. And you can just copy and paste this number that I had lower or below on that chunk and just add there. So this is going to do the trick for us. So kilograms per hectare is just pounds per acre times that number that I provided you there. And if you just run this, and if we just print soy K_3 below here to see what happened, you see, because we started with soy K1, remember, we did not use the filter version. And we just click on this arrow to see. Now we have this last column here that is the K rate in kilograms per hectare. However, notice how it is like it has multiple decimal places after the period there. And I mean, we could leave it if we wanted, but it's really not that useful, right? Because this rate doesn't have to have that level of precision. So to fix that, I just want to ask you to come back to the code, add a comma, hit enter, and we're going to basically overwrite on top of that K rate kilograms per hectare column. So we just paste that name again, you say equals, and then we're going to use this function called round. So we say round, kilograms per hectare, or K rate kilograms per hectare, add a comma and a 0. So this is basically going to take that column that already exists. It's going to round it to have 0 decimal places or spaces. So if we just run this, let me just go back to my code so you can see, and we print it. And now I go again to the end of that data set to see the last column. We see that now the potassium rate in kilograms per hectare has 0 decimal places, which is what we really wanted, right? Okay, I'm going to leave this just for 2 seconds, and then we're going to move to the next chunk. All right. So looking at our data set now, the first thing we did was to clean the names. And then the next thing that we did to the entire data set was to transform pounds per acre to kilograms per hectare. Now, if you think about it, I just want to show you again this data set again, just for us to take a look at it. If we want to do a modeling, or if we want to run a model that has the block effect as part of the model, that means we need to have a column with that information. We need to have a column saying block or rep, and then having 1, 2, 3, or whatever it is. And right now, we don't have the column, right? So if you see here, we have plot, treatment, stage, K potassium rate, and then all the potassium concentration different for locations, and the potassium rate in kilograms per hectare. So we do not have the rep column, and we are going to need it when it gets to creating the models. Now, if you guys, and I know some of you, and I know some of your projects, if you think about it, if you just look at this data frame, can you see any column that could help us to retrieve that block number or rep number from the columns that we currently have? Anyone has any guess? If you want to just put that in the chat, or maybe even speak up if you feel comfortable. Okay, nobody said anything yet, so I'm just going to go ahead. All right, somebody said something. Let's see. Let me open my chat. Yes, Luis said plot column. Perfect, Luis. That's exactly it. So if you think about it, most of the time when people plan studies, field studies particularly, and maybe other types that I'm not, but anyways, in this case here, a field study, usually the plot number the first number of the plot number indicates the rep, right? So we know that all the plot numbers in the 100s are block 1, and the 200s block 2, and so on. So we're going to use that information to create this rep column here in the next step. So if you come here on the next chunk, we have the soyk_4, and we're going to use the get sign and the go. So just to tell you again, the goal here is to create the rep number, the block number column in our data set. So we're going to use again a mutate function, and the first thing we give to this function is the data set we're starting, right? In this case, we're starting with soyk_3. So I'm just going to copy that, paste here, soyk_3, add a comma, hit enter. And then the name of the column that I want to create is rep. I'm going to say equal. And here's the logic that I want to use. I want to tell R that every time plot number is between a minimum and a maximum value, that means the rep should be X. For example, if plot number is between 100 and 200, then block number is 1. And just follow that logic. If you think about it, it's kind of like an if-else statement. And we could do this with if-else statements if we wanted. It's just that we will have to have 4 nested if-elses that don't really make too much. They make sense, but they're not very easy to understand what's going on. And for that, there's a function called case when that helps us with those otherwise nested if-else statements. So we say here rep equals case when is the function name. So you would just open and close parentheses there and just hit enter and have your cursor right below here, just so it's easier for you to read. So the condition I want to create is if plot number is greater than, is greater than 100, then block is 1. Not really, right? Because everything is greater than 100. So we have to define that upper limit as well. So if plot is more than 100 and plot is lower than 200, then, and we say then by adding the tilde sign, wrap is going to be equals to 1. And then after that, you just add a comma, hit enter, and we're going to repeat this condition here for the other plot numbers and wrap numbers as well. So the next one would be if plot number is greater than 200 and plot number is less than 300, then wrap is 2, comma, enter, and this. And we're going to do this one more time for the 300s. So if plot number is greater than 300 and plot number is less than 400, then wrap is 3. And finally, because we only have 4 blocks, we can just say if plot is greater than 400, then wrap equals 4. So that's how we're using case when to establish conditions and create a new column based on a column that we already have. So if we just run that and we print soy K4, I'm going to leave it up there so you can see the code in case you're still catching up. But if you just come here, you're going to see, so we have wrap 1, 2, 3, 4. And if we just go back left again, just to see the plot number, we had 100s, 200s, 300s, 400s. So it did work. We were able to retrieve our wrap information from the plot information using the case when. Okay, so I'm going to leave it just a little bit longer, just if anyone's trying to catch up. And I'm going to move on right now. Okay, so the next step here is the following. If we, so, you know, I told you that this data set here, and you can kind of see up here, is they measured potassium concentration on trifoliates from soybeans in 4 different locations, right? And if you were following from the beginning, you heard me saying that the locations are A1, O2, S1, and W1. So I want to ask you the following. So if we want to model these locations, if we want to have the location effect in a model, we have to have a column saying location, and we have to have the cell saying the location name, right? Which we did not have yet on this data set. And again, I want to ask you, can you look at this data set and where is the location information right now? Like if anyone was just want to spit that out on the chat, where is that location information? Gonna give a second here just to see if anyone jumps out and helps me here. Right, somebody did. Okay, yes. So Ednaldo said A1, O2. Yes. So if you look at it, the location is on the column heading, right? It is right there. Is that A1, O2, S1 is location information. And imagine that this could be, you know, something that even if you have like one study and you're taking some type of measurement every week or maybe every month that you're going out to your plots and taking notes, perhaps you do have one paper sheet where each column is a date that you go out and you're taking notes on that same sheet consecutively, you know, or just something like that, that you're taking multiple measurements and each one of them go into a column. These are cases where maybe on the field it makes sense to take measurements, consecutive measurements on different columns, but then you bring that into Excel and then you want to model this, then all of a sudden doesn't make that much sense to have that information that in this case is location as a column heading, right? So our goal here in the next chunk is going to be to retrieve that location information and take it outside of the column heading and bring it into the data frame so we can use it for plotting or modeling. So let's call this soy K5. If you want to come down to the next chunk here, use the get sign, and there is a function called pivots underscore longer. So in the past, there was another function that was called spread it is still part of the tidyverse and dplyr, but it has been superseded by pivot longer, meaning that now tidyverse developers are providing support, continuous support for pivot longer, and they're not updating spread anymore. So pivot longer is kind of coming to replace what spread used to do. So maybe you're already using spread. I until this day, I still sometimes use spread, but I'm trying to shift my mindset and try using more pivot longer. So that's what I want to show you here. So for pivot longer, for this function, the first thing we want to give it is the data set name that's going in, which is that soy K underscore 4. And then we add a comma, hit enter just to make it easier for you to see the code. And then it has this argument called names 2. Oops, sorry, not that. Names underscore 2. And actually, let me just stop here for a second and take a step back, because maybe I just went a little bit too fast on my logic here. So what we want to do is to take these 4 columns here, the A1, O2, S1, W1, and right now there are 4 columns, but what I want to do is take their values, each one of those values, and put like right underneath each other. So column 1, 2, 3, 4 with the values. So now we have all the values in one column only, but we also going to need to create a new column, which is going to be location, and that's going to have the current column names go under here. So let's say for A1 KPCT, right, is this column here. We're going to take the values of that column and put under value, and we're going to take that name A1 KPCT and populate on the side on another column, and do the same thing for the other 3 locations as well. So that's the goal of this pivot longer function here. So the names 2 is basically the name of the new column that we're going to create that's going to have all the current column names. So I want to call that location.k, like that. And now add a comma, hit enter, and there is another argument called values2. So the values2 argument is for you to specify what's going to be the name of the new column that's going to have the values underneath it. So let's call that just K underscore PCT, and add a comma, hit enter. And now we need to say which columns we want for this to happen, right? Because if we don't say, like we could do this for all columns, meaning that it's just going to put everything under, I mean, it's kind of a crazy example to explain by just using a screen like this, but it's not what we want. We have to say which columns we want the pivot longer to apply this logic to. And there are different ways of doing this, like to specify which columns you want. We could just say, spell out the name of those 4 columns, like A1, KPCT, O2, and so on. But there is a helper function here that is called contains. So we can just use that function here and say, take all the columns that contains the characters K underscore PCT. And if we look at this data set up here, the only columns that have KPCT on them are the 4 ones that we're after, are these 4. So pivot longer is going to look into all the column headings, is going to see the ones that contain this pattern, which is K underscore PCT, and is going to apply the logic of reshaping from wide to long in our data set. I know this, if it's the first time you're thinking about pivot longer or gather, the function gather that pivot longer is replacing, it can be a little bit confusing. So let's just run it and look at the result that may make things a little bit easier to digest. So look what happened here. We still have plot, treatment, stage, potassium rate in kilograms per hectare, and rep. And now we have this new column called location K that is basically just repeating the headings that we had up here. And now we took the values under each one of those headings and populated here on the side. So now we have a column that has that location information, right? So A1 is the location, O2, S1, W1. Of course, it still has some extra stuff there, but at least now we have a column that it's going in the right direction of getting that location information. And now we have another column that is just with the potassium percentage value itself, right? And also something to notice is the data set that we had before had sting rows. And now because we took 4 columns and basically stacked them, now we have 64 rows, right? And this is what you would expect to happen. And if this still doesn't make sense, you can come back to this later and play around with the data set and see what's doing, really inspect closely. But it's just reshaping in a way that now we retrieve the column names under one column, a new column called location.k, and the potassium percentage values in a different column. Okay, so, getting towards the right direction, but I still imagine that you're gonna have a plot eventually, and then you're gonna have your location effect as color, for example, in a plot. And then your legend is gonna say A1 KPCT. Not ideal, right? Because I mean, we don't really need to have that underscore KPCT there, because that's not telling us anything new on this column here. We really only want that first part before the first underscore, which is the actual location name. So let's separate these things here, separate the actual location name from this extra information that we don't need. So if you want to come here on the next chunk, it's called separate. And what we're going to do here is use the get sign and then the function again called separate. The first thing is again the data set, right? The first argument is data set coming in, which is going to be soyk_5, which is the one that we just did above. You can add a comma and enter just to help you visualizing the code. And the next thing here is we say which column we want to separate. So if we just look again, it's the location.k. That's the column name that we want to separate. And R is going to look into this and is going to see a common separator, right? Which is the underscore. And if you just split on the underscores, you end up with 3 pieces, right? The A1, the K, and the PCT. So here on the separate function, it has an argument called into that we need to provide the new column names of each one of those pieces. So the first one I want to call location. The second one I want to call just K. And the third one I want to call PCT, just like that. So we're basically providing like a concatenated character sequence or string sequence with the names of the new columns that are going to be created from separating these strings here, right? So if we just run that, and then you come here and you just say soyk6 and you print it, look what happened now. We don't see anymore that location.k column because that was turned into this. So basically it took this one, saw where it had the underscores as the separator, and then it broke that string into 3 pieces. Perfect, right? Because now we do have a location column that only has a location name. It doesn't have any of this extra stuff, the KPCT, that we really didn't need, right? Okay, so now let's say that this is it. Like now my data set has my treatment in English, in international units, so K rate kilograms per hectare. I do have the block information, the rep. I do have location. And if you go to the right here, I do have KPCT. Those are really the columns I need to make sense of this data, either by plotting and or by modeling. And the next step I want to show you is to just apply a select. So select, you can think of select as kind of like filter. Filter works on rows, select works on columns. So we're just going to select the columns that we need to keep on in our analysis. Now, this is not something like you could just, if you wanted, you didn't have to use a select function here. But because we have a whole bunch of extra columns that are not really going to help us or even be needed in the continuation of this workflow, I just want to select the ones that will be useful so we don't get all these extra columns on the way. So for that, we're going to come on the next chunk here. It's called soyk_7. You can just use that get sign again. And the function is called select. But before we actually do go any further here, I just want to call your attention that there are many packages that use the function select, or sorry, not that use, but packages that have their own function called select. And many times I came to have the error of like using select like I'm doing right here, thinking that is coming from the dplyr package, which is the one that we actually want to use. And I keep getting this error, and the error message does not make sense. And I'm like, what is going on here? And then it took me a long time to realize that the select function that I was using was actually coming by default from a different package and not dplyr. And it was just not doing what I wanted, because it is a function that has the same name, but has totally different functionality because it's coming from a different package. And I'm just telling you all this because if you don't do the trick I'm going to show you next, you'll probably at some point run into this issue and bang your head against the wall because you don't know what's going on, doesn't make sense until you realize. So avoid banging your head against the wall, and let me show you how to avoid all this confusion. So every time you want to force a function to come from a specific package, we can just call the name of the package, like dplyr, which is where the select that we want is coming from, and : : So if you do this, the select function we're using here is coming from the dplyr package. Even if you did not use this part here, if you just delete it and just use select, if this behavior brings select from another package, but still you can force it to come from dplyr by using package name, then : : Okay. So this is, it's a little bit extra talk on my part, but I think it's really important because the chances are you're going to run into this issue at some point in your analysis. Okay, so we're forcing the select function to come from the dplyr package, and again, the first thing that we provide here is data set name coming in, so that's soyk_6, right? And then just looking at this data set here, that is the soyk_6 up here. So plot number, we did not need it anymore. We already used it to extract the rep column, so we don't need that. Treatment column here is just, we don't really need it because treatment number is not useful for us. We already have a column that is the treatment rate, which is actually what is meaningful for us. So we don't need that. Stage here is all the same. It's all R4 for all the observations. So also not really useful. Potassium rate in pounds per acre, in our case here, not useful. If you were doing something for farmers, in Kansas or something with a US audience, maybe you wanted that, not our case, so I don't want to take that. Potassium rate in kilograms per hectare, yes, I want that column. So I just want to copy and paste that here as it's being selected. The rep information, also important, I want to keep that. Location, it's also important, I want to keep that. So I'm just typing here on the select the potassium rate, kilograms per hectare, rep, and location. And then finally, so K, useless for us, PCT useless, but then KPCT, which is the actual percentage values of potassium in the trifoliates, is useful, right? Is our response variable. So these are the columns I decided to keep here. I want to run this and just copy and paste and print so you can see. This is our final data set. So 64 rows and 4 columns, and those are really only the columns that we're going to need to do any plotting or modeling on this data set. So this data set has gone through data wrangling, and now it is at the final stage that we say, okay, this is what we needed. Perfect. Let's move on to the next steps after data wrangling. However, before we actually do that, I still have a couple more data wrangling functions that I want to show you here that are not going to make a difference for us in this data set, but I just want to show you in case you want to do that at some point. So let's say we wanted to sort our data set. So right now you see that it's basically sorted by potassium rates and then rep. Let's say I wanted to sort by location. So have all the A1 values all following each other instead of having all mixed right now. So for that, it's kind of like, it's basically sorting the data, but the function name is called arrange. So let's call that soyk_8. I want to use the get sign. We're going to use the function name arrange. And again, the first thing is the data set coming in, which is soyk_7. And if I want to arrange that by location, I just say location here. Right, so we can run it and just gonna print it here so we can check the results. And we see now that it's been sorted by location, right? So if we keep coming here, we see that values are following the location information. Awesome. And we could have sorted by more than one column, or maybe just by a different column. You know, it's just wanted to expose you to this this function. And now to show you another very interesting combo, I guess, on the data wrangling world is, let's say that I really just wanted to know, as like an exploratory exploration of this data set, I just wanted to know what is the mean potassium percentage on a location basis. So for each location, what was the mean over all the reps and over all the potassium rates for that specific location. So to do that, we have to, it's a two-step process where we first have to use the function group by to establish what is or are the grouping factors that we want to do something over, and then use the function summarize after that to actually apply that summary on the groups that we created with the group by function. So let's start here on the soyk9, use the get sign, use the group by function. And again, we start off saying the incoming data set, which is soyk_8. And because I want to get the means by location, I'm just gonna say here, location, right? So if I print this, or sorry, if I run this soyk9, and I wanna use here, the class function just to look into, wait, let me stop right there and take a step back. Let me print the soyk_9, which has been grouped by, right? So we see that it still has 64 rows, just like soyk8, which was the data set that went into the group by, which is this up here, still 64 rows, still looks almost the same. The only exception is if you look at soyk8, which we're looking right here, it says that it is a tibble, which is a type of data set. And when we look at soyk9, when we printed, it is also a tibble with the same dimensions of soyk8, but now it has this extra information that's the groups. So it's saying us that this soyk9 has been grouped by location and it has 4 groups. So behind the scenes, the group by changes slightly the configuration of this data set, but it doesn't do anything yet. And that's to actually do this, the summary that you want to have, you need to follow the group by with a summarize, which we're going to do here on soyk_10. So here we just use the get sign, and then we say summarize. That's the function name. And it has to be a grouped data set, which in our case is soyk_9. It would not have worked if we use soyk_8, which was not grouped at that level yet. Soyk9 has been grouped. So now soyk9, let's just hit enter here to give us some more space. And let's call this like mean k_pct. So this is the column name that is going to have the operation that I'm going to ask right after it. So I say equals, and then I ask for the mean of the column k_pct. Okay. So then if we run this and now we print soyk10 below here, it should have, and it does have in fact, only 4 rows. 1 row for each location, having the mean k_pct for that location, being that this is the average across all the reps and all the fertilizer rates of the study. So remember, so here we got the mean, right? We could have gotten the minimum value, the maximum value, the median value, the standard deviation. So those are all different functions you can use here inside the summarize to get a summary of your data based on a grouping that you established on the group by function. Okay. All right, so now if we look at this, I mean, look at how many intermediary objects we created here. So starting with soyk1 and then going 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through the summarize. So we created 10 objects, intermediary objects that we really do not need, right? And it kind of bugs me and probably you too to see all these intermediary objects that in the end we don't need them. And there is a way to solve this type of issue, which is using the pipe. I don't know if you've heard about the pipe already or not, but the pipe is something that once you learn, you're going to use this a lot. I swear to you, it's a game changer if you keep doing data wrangling, and even not only data wrangling, but doing things in sequence like we did here. The pipe is going to be a big help. So the pipe operator is basically this. It's like a percent greater than percent. So what the pipe does is it takes, let's say, we have X and Y here. You don't have to type this because it's not really a function. It's just more to make the point that what the pipe does is it takes whatever it's on its left and pipes that through as the input of the function on its right. So that's all it does. Takes whatever is on its left and uses that as the input of whatever it's on its right. That's it. So I want to show you here. Oh, we got a comment. Let's just check. Oh yeah, Carlos just showed a shortcut there, Control-Shift-M on Windows PCs. So that would be the shortcut if you just want to use that. It's going to be really helpful because you're going to see now we're going to use a lot the pipe. So here's what I want to tell you of what is my goal in the next chunk, and I'm going to show you how I will do that. My goal is to, starting with soyk. So remember that soyk was just a data set coming straight from Excel. So with all the crazy column names and all that, starting with soyk and going all the way through until soyk7, which is the select. This is where I want to basically stop on whatever we did here on soyk_7. And I want to do that using the pipe. So avoiding creating all those intermediary products and just having one product that we're calling soyk_w. And the W is for wrangled. That's how I usually name my objects that have been through data wrangling already. So starting with soyk, let's just add a pipe. And it is the convention that after the pipe, you hit return, you hit enter on your keyboard just to be able to see things better. So we hit the pipe. And now the first thing, I'm going to go back here on my table of contents. If you're not seeing your table of contents, just toggle this button here on and off. like that's going to show your table of contents. And you may not be seeing the chunk names. And if that's the case, don't worry. It's just an option on your Rstudio. But I am seeing, so I'm going to use the chunk names to go back to those chunks. So we're going to go back to soyk_1, and the function we used was clean names, right? So I'm just going to copy whatever is on the right side of the assignment, copy that, and then I'm going to come here on the piping it all together, and I'm going to paste it. Now, however, because the pipe is already given soyk as the input to the clean names, I did not need to specify soyk inside clean names. So that's how you would do it. So if I just run this, right now, this object is exactly the same as soyk1, where we have the column names standardized. However, we still only have 16 rows and still have a lot of stuff to do, right? So now after clean names, I just add another pipe, hit enter, and go back to my table of contents. I'm going to skip the filter because we really want to keep the entire data set going through. So I'm not going to do the filter on the pipe. I'm going to come on the mutate here where we transform pounds per acre to kilograms per hectare. And again, I'm only going to copy everything that's on the right side of the assignment. And I'm going to go back to the piping it all, paste it here. And again, now we do not need to specify the data set here because that is already being done by the pipe. So if I just delete the data set specification there, this is what we end up with. And if you think about it now, on the mutate function, the incoming data set is not soyk by itself anymore. It's already the product of everything before the pipe. So all this is the input of the mutate function, right? So now continuing here, I'm going to do this a little bit faster, just so we, we don't get behind too much. But I'm going to add a pipe, hit enter. So we did soyk1, soyk3, now the next soyk4. So I come on soyk4, copy that, go back to piping it all, paste it, remove the data set specification there because we don't need it again because the pipe is doing that for us. Whoops, I think maybe I missed, I missed parentheses right there. And then gonna add the pipe again, hit enter. Now we go back to soyk, let's see. So we did the case when, so now, now we go to soyk5, which is the pip of longer, copy all that, go back to piping it all, paste it, delete the soyk for incoming data set, and just keep doing that. And just, if you're doing that, just make sure that you close your parentheses properly at the end. So now pivot longer, now it's soyk6, we do the separate. Okay. Come here, paste it. Make sure your parentheses are closed right, add the pipe, hit enter. And now lastly is the select. So whatever we did on soyk7 is the last part. Copy from there and paste it here. And I think I got all of my, so if you see here, starting with soyk with clean names, created the potassium rate in kilograms per hectare, used the plot column to create the wrap, and then change the configuration to retrieve the location name as a column. And then we separated that extra column into its pieces and then only kept, oh, wait, I actually have to remove here. Yeah, I was almost making a mistake. So I excuse me. I almost left the incoming data name as it was above. So we did all that. If you run it and you got your parentheses closed correctly, it should be all right. And now if we print soykw, it should give us the same result as what soy K7 was. Okay, I'm just going to leave here just for a brief moment for you guys to catch up if you need to. Awesome. I'm going to move on. And now, so this is exactly the same as what soy K_7 gave us. And then you can see how, normally, once you learn how to use the pipe, you really use it a lot. And if this was my data set that I was starting myself, just, was not in a teaching environment, this is what I would have done from the beginning. I would have used the pipe from the beginning. I would not have saved all the in-between products. So this is just, it's just to show you that you can do it with all the in-between products, but there's really an easier way of doing all this, that is by using the pipe. Okay, so now if you were able to get through this, I just want to save this version here, the final wrangled version that is ready for plotting and ready for modeling just save that to file so we can use that data set going forward. So for that, let's use the write_CSV function. I want to save this as a CSV. The first argument is the data name, right? So it'd be soy K_W. You add a comma, and then open and close quotation marks. Have your cursor blinking in between the quotation marks, and we're going to get outside of this folder. So .. If you hit tab, you're going to see the main folder contents. We want to go inside the data folder because now this is a process data frame. If you just hit tab again, you're going to see the soybean workshop.xlsx. I want to ask you to delete that xlsx and go until soybean workshop and just add the word processed. And then after that, add .csv. So if you run this and you are successful and you come here on the right-hand side on the Files tab under the data folder, now we're going to have a new data set that is that soybean workshop processed one. And here's the thing. So this next session, which we're running a little bit late on that, we're going to have to use the processed version. So the soybean workshop processed. If you were not able to get to this point, we need to know. But we need to help you here, and we can use maybe 5 minutes to help if anyone has issues, because if you were not able to get to the end, you will not follow the next session because we're going to need to use the process version in the next session.